Solving these next two equations, systems of equations by the elimination method, we'll notice a couple of things. On this first one, if I decide to eliminate the x's, I want to think about what do both 3 and 9 divide into, and they both divide into the number 9. This is already a 9, so I don't need to do anything with this bottom equation, but the 3 needs to be a negative 9 because I need to add and have the x's cancel. So to make that happen, I'm going to have to multiply by negative 3 to that row. So the equation on top becomes negative 9x minus 6y equals negative 9. The bottom row, positive 9x plus 6y equals 7. Now notice when I add these up, not only do my x's cancel, but so do my y's, and I end up with nothing, or 0, on the left side, equals negative 2. I have no more variables, and I come up with a false statement. And in math, when that happens, your solution is you don't have one. There's no solution, which means there's no place that both the x and the y, or there's no coordinate that both of those lines intersect. If the two lines never intersect, then we can think about what the picture may look like, and that's the two lines are parallel. But our final answer is there is no solution to that system of equations. For the second system of equations, if I want to eliminate, let's say, the x's, I once again have to think about what do both 2 and 3 divide into, and they both divide into 6, which means one of these numbers has to be a positive 6, the other one has to be a negative 6. And it doesn't matter which, but I will have to multiply both lines by a number in order to make that happen. So if I want the first number here to be positive 6, I'm going to multiply through by 3 to make that happen. 3 times 2 is 6x. But then every number in that line has to be multiplied by 3. So I have plus 9y equals 3. So in my second equation, the first number has to be a negative 6. So I'm going to multiply by negative 2 times 3. I could have easily multiplied the top by negative 3 and the bottom by positive 2. I just need these two numbers to be opposites. And whatever I multiply that by, I have to follow through. So negative 2 times negative 2 and negative 2 times 0. So when I add those up, I end up getting, what, 13y equals 3, or y equals 13/3. I'm sorry, 3/13. Alright, so again, I have choices. I can either plug the 3/13 in for y and then solve for x, or I can go back through the problem and instead of eliminating the x's, turn around and eliminate the y's. And I often like to do that, especially if I end up with a fraction answer. So I'm just going to start again. Go back to the original, make sure, oh, there's a sign error right there. Make sure your signs are the same, everything's the same about the problem. But now I'm going to eliminate the y's. So again, between a positive 3 and a negative 2, they both divide into 6. I'm going to multiply the top row by 2 to make that a positive 6, and by 3 to make that a negative 6y on the bottom. Right, and then from here, I'm going to go ahead and multiply it out. So again, everything is multiplied by 2, everything's multiplied by 3. I get 13x equals 2, or the x part of my point is 2/13. So my final answer as a coordinate is the x is 2/13, the y is 3/13. And again, you can plug those values in and double check. That point should fit in both lines.